Good morning. Today we're going to be talking about Math 101 and in particular Chapter 4, Section 2, Online Class 4.2. All right, we're going to be talking about graphing linear equations or graphing line equations, or just more simply graphing lines, all right? Now, I'm going to assume that you've seen this topic before in your high school careers or elsewhere. In particular, I'm going to assume that we know how to plot points in the XY plane, right? XY plane looks something like this. Every point in the plane, envision the computer screen or wherever you're looking as a plane that goes off infinitely in four directions. All right. This quadrant, as you might recall, is labeled quadrant 1. The convention is if the intersection of these two axes are the origin, call the origin, and have the coordinates 0, 0. Right? Thus, if you're right of the x-axis, right of the y-axis, I should say, your x values are positive, and if you're above the x-axis, your y values are also positive. So in the first quadrant, x values and y values are both positive. And we label these in a ascending counterclockwise fashion, as you might recall. Right? The two coordinate axes cut off the xy plane into four, what we call quadrants. In quadrant 2, that means your x values are left of the y-axis, and the convention is that x is negative out here. You're still above the x-axis in this quadrant, so y values are positive, right? In second quadrant, x negative, y positive. In the third quadrant, again, you're left of the y-axis, so your x values are still negative, and your y values are now below the x-axis. So note in the third quadrant that all coordinates, both coordinates, are negative, and also in quadrant 4, you're right of the y-axis, so your x values are positive, and you're below the x-axis, so your y values are negative. All right, and again, I'm going to assume that you know how to plot points and generate graphs of lines as you've probably done before. All right, I'm going to jump in and do an example in our text, and they ask us to graph lines. All right, this is example 1A. I'm going to call it example 1A because it's a little bit different than example 1 in the book. All right, but essentially logic equivalent. Y equals 3x plus 2. They give us an equation, y equals 3x plus 2. All right, so what we're going to do, to graph lines, we'll generate what we call a table of values. And I like to ask for 3 points. 2 points to determine a line in the plane, of course, but a third point will confirm and will highlight if you've made a mistake. If these points turn out to be not on the same line, then you've made a mistake. So probably a good idea to get 3 points whenever you're graphing. All right, so once we generate the table of values, we plot the points or plot the pairs of x, y values that we generate in the table, and then we'll label and make things nice in a final product. All right, so here's the equation we are asked to deal with. I'm going to generate the table of values and put it in this fashion. And notice y is solved for in this equation. Y is given in terms of x. So what I can do is just pick x values that I like and generate corresponding y values for my table of values. All right, I'll start out with x equals 0. If x equals 0, y equals 3 times 0 plus 2 turns into y equals positive 2. So when x is 0, y is 2. All right, so I'm going to generate 3 points in this fashion. Let me get some more room here. Again, our goal is a graph here. So again, y equals 3x plus 2. Let me try another value of x. If x is 2, for example, if x is 2, well, 3 times 2 plus 2 will then generate the corresponding y value of 8. So when x is 2, y is 8. And again, let me try something else. Y equals 3x plus 2. Try another x value. Let's say x equals negative 2. So y equals 3 times negative 2 plus 2 gives me y equals, well, 3 times minus 2 is minus 6. Minus 6 plus 2 is minus 4. All right, so I've got minus 4 there. All right, so there's a table of values with corresponding x and y values that we know solve this equation. All right, and these will generate a line in the xy plane as we plot these points. So let me get some more room here. And I'm going to generate an x and y axis here. Now again, I'll do the best I can. All right, so there's my coordinate axes, and I label the coordinate axes. Draw arrows in all 4 directions, labeling x and y as needed. All right, I'm going to want to plot these points now. If x is minus 2, y is minus 4. So there we go, 1, 2, 1, 2, 3, 4. And plot the point right about there. If x is 0, y is 2. Right? If x is 0, well, that means we're right on the y-axis, and y is positive 2. So I'll put that up here. And if x is 2, y is 8. So let me go, x is 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8. I'm going to need some more room here. Give me a second. That y is in the way. Try it again. 1, 2, 3, 4, 5, 6, 7, 8. Again, this is the y-axis here. So when x is 2, y is 8. Right about here. All right, I'll go ahead and try to use a ruler on the tablet. Not as easy as you might think. And it's supposed to be a line, believe it or not. Well, that's the best I could do freehand. You might want to get graph paper, of course, as working out your homework problems. I'll make the dots big here, but I'm sure you get the idea. Once you've labeled the axes, generated the points, you need to label the line with the equation that generates it and move on to the next problem. Okay? All right, let's try another one. This is example 2 on page 242. We are asked to graph the line equation 3y equals 5x minus 6. Now you'll notice here that y is not solved for. We are not given y in terms of x, so it may be a little harder to graph. What our author does first is solves for y algebraically, because then it'll be easier to make a table of values. Well, to solve for y, you've got to divide both sides, all terms, by positive 3. The 3's cancel on the left, so I'll get y equals. And on the right, I can break up my numerator difference over a common denominator. And of course, 6 over 3 reduces to a 2, so I'll get y equals 5/3 x minus 2. All right, that's equivalent to the original equation, 3y equals 5x minus 6. We did algebra type things to get from here to here. So equivalent equations, same graph in the xy plane. Let me make a table of values. All right, if I pick my values of x with a little forethought, I'll have an easier graph to draw. Well, I see this minus 3, in the denominator here. And of course, I want to try to stick with whole number coordinates if possible. If I pick my x values as multiples of 3, then they'll be canceling out with this denominator, and I'll have corresponding whole number coordinates for y as well. All right, so let me pick whole multiples of 3 to sub in for x. And my favorite multiples of 3 are going to be 0, 3, and minus 3. Remember, 0 is a multiple of everything, right? All right, so what I'll do is generate my table of values. First, I'll plug in minus 3. Well, if x is minus 3, I'll say y equals 5/3 times minus 3 minus 2. 3 cross cancels into minus 3 negative 1 times, and 5 times negative 1 is negative 5. So I'll have no fraction anymore, and that's the first slot on the right. And minus 5 minus 2 is, of course, negative 7. So when x is minus 3, y equals negative 7. And no need to go to the calculator here or any of that, if you pick your x values with little care. All right, if x is 0, I'll get y equals 5/3 times 0 minus 2. Well, 0 times anything is 0, so y equals 0 minus 2, which is, of course, negative 2. So when x is 0, y is minus 2. All right, similarly, what happens when x is 3? Well, I'll plug in x is 3. Y equals 5/3 times 3 minus 2. The 3's cross cancel, and I end up with 5 minus 2. And 5 minus 2 is, of course, positive 3. So when x is 3, y is 3. All right, so with a little side work, we've generated our three pairs of ordered values. And now I'm ready to go ahead and graph. Yeah, let me scroll down a little bit. I'm going to keep as much in the frame as I can. All right, the straight edge doesn't seem to be working very well on the tablet, so I'm going to go ahead and do this freehand. Again, doing the best I can here. Y-axis, x-axis. All right, when x is minus 3, y is negative 7. 1, 2, 3. Negative 7. 1, 2, 3, 4, 5, 6, 7. Puts me about here. If x is 0, y is minus 2. Well, if x is 0, that means you're going to be on the y-axis, right? So I count down 2 units from the origin on the y-axis. And if x is 3, y is 3. So 1, 2, 3. 1, 2, 3 puts me up here somewhere. And it indeed looks like these points are collinear. All right, I'm going to try to freehand it here. Oh, not too bad. Okay, so there's our line. I'm going to go ahead and label these points. When x is minus 3, y is minus 7. When x is 0, y is minus 2. And when x is 3, y is 3. All right, so I've drawn the axes, labeled the axes, drawn the points, labeled the points. All I need to do now is label the line. Now you can label it with either form of that equation, either the solve for y form or the given form. What was it? 3y equals 5x minus 6, right? All right, either one of these is fine to label the line. Okay. Next. I need some more room here. Hang on. All right, this is example 3 on page 243. All right, they give us 2x plus 5y equals 0. All right, well, if we solve for y, like we did in the past two examples, well, I'll get 5y equals, I'll subtract 2x from both sides, and minus 2x plus 0 is, of course, minus 2x. I'll then divide both sides by positive 5, and I'll get y on the left, the 5's cancel out, equals minus 2/5 times x. Y now is in terms of x. All right, I'll generate a table of values. And again, I'm going to pick x values that are multiples of 5. All right, so I'll get a nice cancellation with that 5 in the denominator and only have whole number coordinates to deal with. All right, I'm going to pick 5, 0, and minus 5 for x values. And let's do minus 5 first. All right, if y equals minus 2/5 times x, if x is minus 5, I'll just plug in minus 5 like so. A negative times a negative is a positive. The 5's cancel out, and I get y equals 2. So when x is minus 5, y equals 2. Okay? Try another one. All right. Again, y equals minus 2/5 x is our solve for y equation. If x is 0, well, 0 makes it easy, right? 0 times anything is 0. So if x is 0, y is 0. That's really the origin, isn't it? All right. Again, let's get that third point now. And y equals minus 2/5 times x. If x is 5, what's y going to be? Well, here the 5's cross cancel, and I'm left with y equals negative 2. So there's our table of values. All right, let me go ahead and generate the graph now. Make some room here. All right, here we go. I'm going to put the converted equation up here. Either one is fine. Again, I'm going to do this freehand. Y-axis, x-axis, not too bad. All right, if x is minus 5, y is positive 2. All right, so 1, 2, 3, 4, minus 5. Y is going to be positive 2. All right, so I'll go ahead and label that point, or the coordinates of that point. All right, remember, x is the first coordinate, y is the second coordinate in general. That's the convention. X at first in ordered pairs, right? All right. If x is 0, y is 0. And puts me at the origin. And if x is 5, y is minus 2. So 1, 2, 3, 4, 5. Y is negative 2. Count 2 down and 5 to the right. And it looks reasonable to claim that these 3 points are collinear. Again, let me try to draw it without a straight edge. Not too bad. There's my line. I've labeled the axes. Probably should label these other 2 points. And of course, label the line with the equation that generates it. You can pick either form, this or this. I'll probably go with the converted form, a little less ink. All right, so that's example 3. Example 4 and 5, the book asks us to graph using intercepts. Now let's talk about intercepts. Intercepts are nothing more than where the line intersects the coordinate axes. If I've got a line drawn in a coordinate axis, this point here is what we call the y-intercept, because that is where the line intersects the y-axis. Now, a y-intercept will always have a coordinate of 0. An x-coordinate of 0. The y value, I suppose, could be anything depending on where it hits the y-axis. X-coordinate of y-intercept is always 0. Always, okay? That's how you can recognize a y-intercept from a table of values. Similarly, where the line intersects the x-axis, that's going to be the x-intercept. And x-intercepts always have the form where the y-coordinate is 0. If y is 0, that means you're on the x-axis somewhere. Right? H2, 4, 4 gives us this equation, 3y equals 6x plus 12, and the book wants us to graph using intercepts. All right, that means there's only 2 intercepts here. All right, so we're not going to be using 3 values, but intercepts tend to be easy to find. Well, not always, but most times. I'm going to want to let x be equal to 0 to solve for y. That'll give me the y-intercept. And if I let y be 0 and solve for x, that'll give me the x-intercept, right? All right, so let's look at this y-intercept first. If I let x be 0, I plug in x equals 0, and I'll get 3y equals 12, or y equals 12 thirds, or y equals positive 4. So when x equals 0, y equals 4, right? Similarly, if y equals 0, I'll sub in y equals 0. I get 3 times 0 equals 6x plus 12. Of course, 3 times 0 is 0, equals 6x plus 12. I'll subtract 12 from both sides. I get minus 12 equals 6x. And dividing both sides by 6, I get x equals, of course, negative 2 on the left. So when y equals 0, x is negative 2. And I claim that's just enough information to graph my line equation. Let me erase this work here, and I'll go ahead and generate the graph of the line. Y-axis, x-axis. If x is 0, y is 4. Oops, sorry, made a mistake there. Let me try it again. If x is 0, that means I'm on the y-axis. Y is positive 4. All right, notice this is the y-intercept. So the x-coordinate must be 0. And similarly, if x is minus 2, y is 0. And if your y-coordinate is 0, you're on the x-axis. All right, there's the y-intercept, there's the x-intercept, and that's plenty enough to generate the line. So let me go ahead and connect the dots. There's my line. Not too bad. There's the labeled intercepts. And of course, label the line with the equation that generates it. 3y equals 6x plus 12. All right. Example 5 is similar, but I think this situation, the author sticks us with some coordinates that are not whole numbers. And that's the first time we've seen that today. So beware. This is example 5 on page 245. 2x plus 5y equals 12. The book asks us to graph using intercepts, namely the x and y intercepts. All right, so I could make a table of values here and say if I want to find the y-intercept, I let x be 0. And if I want to find the x-intercept, I let y be 0. All right, let's work on the y-intercept first. If x is 0, I sub in x equals 0, and I'll get 5y equals 12, dividing both sides by 5. I get y all alone on the left. Y equals 12/5. I can't really reduce that. Now, don't go to decimals and don't go to, mixed numbers here. What I'm going to do is do my best to graph this as an improper fraction. Okay? Well, 12/5 is somewhere between 2 and 3, right? I'll worry about that in a minute. Now, I'll find the x-intercept by letting y be 0. Well, 5 times 0 is 0, so 2x equals 12, or x equals 2. All right, so luckily we've only got one fractional coordinate to graph here. All right, let me clear this work away, and we'll generate the graph. Y-axis, x-axis. If x is 0, y is 12/5. Well, 12/5, 10/5 is 2, right? 15/5 is 3. So this is going to be 2/5 of the way between 2 and 3. I'll put it right here on the y-axis. All right, I'll go ahead and label this intercept. If x is 0, y is 12/5. That's the y-intercept. If x is 2, y is 0. And remember, when y is 0, that means you're on the x-intercept. X is 2, y is 0. That's the x-intercept. And I'll do my best to connect these dots in a steady hand fashion. All right, so there's the line. 2 points determine a line. And I label the equation now, 2x plus 5y equals 12, with the equation that generates it. Okay, so sometimes coordinates are fractions, and we just have to deal with them. All right, one more subtopic we want to talk about today before we call it a day is horizontal and vertical lines. All right. Graphing horizontal and vertical lines. All right, well, let's start out with a horizontal line. Well, let's see, I'm going to graph an equation, looks something like this. I'll say graph y equals 3. And you may say, well, it doesn't look like the other ones. Where's x? Well, there is no x. All you're saying here is y equals 3. Well, in essence, you're saying it really doesn't matter what x is. Y is always going to be 3, 3, 3. Right? So x can be anything. and y will always be equal to 3 in this equation, right? This represents the set of all points in the xy plane that have a y coordinate equal to 3. All right, so if this is the y-axis and this is the x-axis, and I want to graph y equals 3, well, 1, 2, 3, it's just, let me do a different color here. It's simply a horizontal line, because y never changes, with an intercept of y equals 3, and y-intercept of y equals 3. All right, so graphing horizontal lines are a little easier than graphing other types of lines, and nothing sacred about y equals 3 here. Anytime you've got a task to graph something of the form y equals some constant, let me write that out. If y equals constant, 3 or otherwise, well, that's going to be a horizontal line, just like the one we've graphed above. Horizontal line, okay, with the y-intercept, well, whatever that constant is. Y equals constant, horizontal line, okay? All right. Let's talk about vertical lines. Let's say we're asked to graph something of the form, let's say x equals minus 2. And again, like the last one, you might say, this looks weird. This here, y doesn't appear. Yeah, that's right. Y does not appear, and that tells us something. This tells us it doesn't matter what y is. X is always going to be negative 2, negative 2, negative 2. The x coordinate is never going to change. X equals constant. And here that constant is negative 2. All right, so if I sketch this graph, this is the set of all points in the xy plane that have an x coordinate of minus 2. In other words, x never changes. Get a different color here. And if x never changes, you've got a vertical line. Right? So x equals constant, vertical line. Okay? Let me write that down. X equals constant, no matter what it is. You can have something that looks like this. Vertical line. Right. Y equals constant, horizontal line. X equals constant, vertical line. Let me write that out one more time. Y equals constant means horizontal line. Let the bell go off in your mind. Horizontal line, parallel to the x-axis, right? And similarly, x equals constant gives us a vertical line. All right. All right, this concludes section 4.2, graphing line equations.